Thank you. Thanks all for joining. So today I'm going to take a few moments to walk you through some technology that we are building at the Eclipse Foundation together with several partners to help people build machine-to-machine Internet of Things solutions. So I will walk you through the projects that we have and make you a quick demo of some of them. So a few words about myself. I'm Benjamin Cabé. I'm with Sierra Wireless. We do basically M2M hardware. We manufacture wireless modems, wireless gateways, and we also sell server-side services, like to manage a fleet of devices and manage all the software running on devices on the field. I've been using Eclipse for a long time and contributing on several Eclipse projects. I'm a committer on several Eclipse projects as well, and this is probably one of the reasons why I'm pushing so hard to have as many projects as possible to help to have, as the title of the talk says, have building blocks, open source building blocks for building M2M solutions and IoT solutions. What's M2M? What's IoT? I think you guys, if you've been in the room today, you've heard about the M2M already. In a nutshell, these are all the technologies that enable connecting objects, devices to the internet, have them communicate with each other. Like that would be maybe a car. You have an accident. You want to report your location to the emergency services. You have an electric car and you want to find an available power station downtown and receive an SMS when your car, when the battery is full. For example, you want to do smart grid, optimize the distribution of electricity in a specific area. You want to take care of patients at home and have ways to monitor their vital parameters. And speaking of a medical use case, the typical architecture would be something like this, where you have basically some devices that are your medical devices, like a smart pill box, a blood pressure sensor, and they are communicating with the internet using a gateway. We have some logic at some point on a device between the assets on the field and the internet for having some intelligence to maybe consolidate the data and understand what all the sensors are basically saying, what's the information they are collecting. And in this gateway, you are putting some software that will eventually exchange data with the server and receive maybe commands from the server as well. So as you can have the patient using a mobile application for interacting with the devices, or you would have the doctor or the hospital being able to access to the data as well. So on this picture, also of course it's quite simplified, but the architecture looks pretty simple. Still, building M2M solutions is really complex. The market first is fragmented in terms of so many different hardware, like all the sensors, they all run on specific hardware stack. The communication protocols to communicate between the gateway and the sensor, that there are tons of industrial protocols or proprietary protocols. Same for communicating between the gateway, the embedded gateway, and the server. You have people doing HTTP, OMADM, any kinds of protocols. So it's difficult to have some interoperability between all these solutions deployed on the field. The development is complex as well. You have to learn, if you're doing an healthcare solution, you will have to learn all the protocols for interacting with the pill box, with the blood pressure sensor. You will have to master maybe different SDKs for depending on the gateway you use for bridging the existing devices with the internet. You will have to learn maybe different languages as well. You will need to, at some point you are sending your data to a server, so you will need to use a protocol that you understand well, so as you use as few bandwidth as possible. If you go all the way to the end of the chain, you will need to make use of the data that's available on the server, so you will have to write web applications, mobile applications, and again, new technology to master, and usually proprietary technology or monolithic solutions to do that kind of M2M stuff. So this is where we came up with the idea of building an industry working group at Eclipse to have several companies and individuals working on the common building blocks, helping building interoperable M2M solutions, having all the tools, all the frameworks to help people build solutions faster and in a more open way. So as of today, we actually have 3 projects to achieve this idea of an open source M2M. First is an embedded framework, which is called Mihini, which allows to put the actual logic inside the embedded system for bridging existing sensors, existing devices on the field with the internet, with the server. Then we have a project called Paho, which brings all the implementations of the protocols that we think are the ones that are the most efficient and the more open for doing M2M. Their specifications are open, their implementations are open, like as in open source. And we also have tools. We are the Eclipse Foundation, so not only do we work on frameworks, but of course, historically, you know that Eclipse is an IDE, Eclipse is about the tools. So we have all the plugins for helping developing the embedded application, simulating complex communication scenarios between devices and the server. You know, when you start maybe prototyping a solution, you don't have all the hardware, but still you want to start prototyping, so that we have simulators in the Koneki project. So that's basically the 3 projects, and the idea is really to address the more painful problems, the most painful problems of M2M development. First of all is the embedded programming. When you build an M2M solution, you are on a very constrained device, so you have to deal with low-level C development. You have to do memory management, manipulate strings, and do weird mistakes with everything related to memory. If you want to do multi-threading, it's going to be quite complex. When actually all you want to do is reading values out of sensors, maybe controlling some actuators, and in general, what you want to do is consolidate the data you acquire and communicate back and forth with the server. It's not that. I mean, you don't want to do very complex stuff when you build an healthcare solution. You just want to take the data out of the sensors and send the data. That's pretty much what you want to do. Same if you want to send, say, an SMS. You don't want to use a very complex C APIs where you have to open the serial port and read some weird characters and talk AT commands with the modem, where all you want to do really is have an API for sending the SMS. So that's how we came up with the idea initially to focus on providing an embedded framework which allows to provide simple APIs and to be really easy to embed. So this is where we started to tinker with a language called Lua. It's a scripting language which is really easy to embed in very small and constrained devices. You need like a meg of RAM, a meg of flash for running the VM and for running scripts. And what we think is interesting in Lua, and we'll see later that Lua is not the only option for building M2M solutions with our technologies, but we think it was interesting to start with that kind of approach, in that we wanted to provide a high-level programming language which is very close to which is actually a scripting language. So you run, you have a virtual machine interpreting your scripts. The language itself is really simple to learn, very limited set of APIs in the core of the language itself. The language is extensible and it's portable. The implementation of the Lua VM is written in pure ANSI C, so you can run it on many kinds of microcontrollers. It's nothing very difficult to port on several. And of course, it's a scripting language, so your code itself is portable. As I said, it's small. The language, the core of the language, the syntax is really simple. but yet it's a powerful language. You have ways to, you have tail call optimization, you have very advanced ways to manipulate tables, to override the way you will manipulate tables. If you want to build, for example, your own domain-specific language, you can tweak the way tables are manipulated for specific objects and have your own DSL. You have, so that's called the meta tables. You have core routines for doing kind of multi-threading, and yeah, the core of the Lua VM is very small, and every extension comes with external libraries, so they are written either in pure Lua or for extensions such as the one bringing sockets, for example. That would be a mix of Lua and C for having, yeah, for accessing the underlying APIs of the OS. So if we were to compare Lua to some other high-level languages in terms of features, it's nothing really funky, but maybe one difference would be in terms of concurrency management. The way the multi-threading is done in the Lua VM, it's not depending on the way threads are being done on the underlying OS. So it's way more reproducible what happens on a Lua VM running on Windows and running on Linux, for example. And the performances of Lua are great in that it's almost as efficient as C. And even though you would have needs for really good efficiency of your I don't know, signal processing stuff, the way Lua is designed is for integrating very well with C. You can basically create a wrapper on top of an existing C library, just like with JNI. You would have a nice Lua API calling a C library, and the other way around. If you want to embed the Lua VM inside an existing runtime, a C runtime, or actually you can do that in Java as well using a technology called JNLua. You can really easily bootstrap a Lua VM and execute some scripts inside your application. That's exactly what people are doing in the video game industry. World of Warcraft, if you were to build your own extensions of the UI, that would be using Lua. In Adobe Lightroom, if you want to have your own scripts for doing some image processing, that would be using Lua as well. They run a Lua VM inside their own runtime. So yeah, a very good integration with C, and as I said, a very restricted set of libraries. The idea is that the language itself is really simple, really easy to port, and if you want to have more libraries for implementing your own stuff like sockets or implementation of industrial protocols, so on and so forth, it's a mechanism of libraries. So why do we use Lua for embedded then? The idea is that historically some of the high-level languages I mentioned earlier, like maybe Ruby and with later on with Ruby on Rails, initially these high-level languages, they were not meant for, I mean, they were quite heavy in terms of memory consumption and so on. So the idea is that with Lua, you come up with something which is not only high-level but also easy to embed in very constrained devices. So we provide actually a framework for developing using the Lua language, and for this we needed to create, and that's one of the first projects we started working on at the Eclipse M2M industry working group, is an IDE. So we have in the Koneki project, we have an IDE called Lua Development Tools, which brings all the nice features you would expect from an IDE, the code completion, everything to navigate through the code, a way to generate documentation of your APIs, a debugger. Even though Lua is a scripting and a dynamic language, we have a visual debugger. We have ways to do remote development, which is important. If you do M2M, you will develop for some embedded device, so at some point you will need to run your script remotely. And we have also what we call an embedded interpreter. Even though you don't have a Lua VM on your machine, you get our tools and you can start tinkering with Lua without even having to install the Lua VM. So I want to show you very few features of the IDE. So as you have maybe an idea of how Lua looks like and how you can use the tools for actually deploying remotely. So I'm going to switch to the remotely. So I'm going to switch to the to my Eclipse IDE. And what I'm going to do is create a new Lua project. And what you'll see is that just like when you create a new Java project inside Eclipse, okay, I will pick a name for my project, of course. And then the other thing I will select is what we call the execution environment. It's the, I'm going to reference what's the set of APIs I'm developing against. Just like when you create a new Java project for doing Java SE 1.5, you will want to have access to a certain set of APIs when you develop, when you want to trigger the content assist. That's the same here. I want to develop against the Lua 5.1 virtual machine. I want to have access to all the APIs of Lua 5.1. So I pick up my execution environment, create a new project, a main is automatically created for me, and now what I can do is basically access to the APIs of the Lua VM, like if I want to, let's do this. If I want to manipulate the I/O library and open a file, I have the content assist proposing all the stuff for me, and I want to open the full file in read-only mode and want to manipulate some stuff on my file. I have all the content assist. Even though the language is dynamic, we have all the parsing features of the language, etc., to provide good tooling. So the language is simple to learn, and still you have support in the IDE for learning it even faster. So that's pretty much the idea about the basic features of the IDE. And if I switch back to another application that I've written here, it's basically a simple main function. And what I want to show you is that I can, from the very same IDE, run my script locally. So for this, I will use a local launch configuration, which is probably configured somewhere already. So yeah, I want to run the project called Hello Koneki, and I want to run it using maybe using the embedded interpreter of the IDE, the one using JN Lua actually, because in order to run Lua scripts from the IDE without people having to install the interpreter, we use the Java version of the Lua VM, and basically you can see that I've been looping through my 10 variables, whatever, and this seems to be my local machine. The very same script, I will use a different run configuration to actually launch the script remotely, and for that I'm leveraging a feature that you might know in Eclipse, which is called Remote System Explorer. I have configured beforehand in my dedicated perspective a few remote Linux machines I have an SSH access to, and I have configured them, and what I want to do is access to this one and, for example, browse the file system. So I'm over SCP and SSH browsing the file system of my remote target. I can open a terminal to do whatever I want on the terminal, like doing this, for example, and show you what's the name of my machine, Linux, whatever, and I can open a Lua interpreter remotely, that kind of stuff. So my remote system is configured already, so if I switch back to the Lua perspective and try to configure a launch configuration, which is this time not a Lua application, but actually a Lua remote application, and I will create a new one in order to run the Hello Koneki sample on this machine. So what will happen here is that the script is being copied to the remote target using SCP, the Lua VM is bootstrapped remotely, and my script is being launched. So this is what we worked on first, provide all the tools for enabling Lua development. Koneki, more information about LDT at the URL. You can download the tools either as a standalone IDE and ready-to-use distribution, or you can use the Eclipse Marketplace, or go, if you use Juno, you search for Lua, and you just install the feature inside your IDE. We provide execution environments for several Lua VMs, not only VMs dedicated to M2M. Lua is used in video game, as I said, so if you want to develop your own video games, we have that kind of execution environments as well. So this is, yeah, we want to start building the solution using Lua. Now we are going to need to do at some point some communications between the embedded device and the server. And as I said, there are many protocols for communicating back and forth with the server. One we think is quite interesting is called MQTT, for Message Queue Telemetry Transport. And it's a protocol invented, a messaging protocol invented in order to have a way to transmit data in a very low bandwidth and low power way, in a way actually with the publish-subscribe mechanism. You would use MQTT for publishing data on specific topics, and you can have embedded devices or whatever clients listening to topics and be notified immediately when data is being sent on the topic. There's a large ecosystem of MQTT clients, of MQTT implementations that are available. And in a nutshell, the way it works, as I said, it's a publish-subscribe mechanism. So you would have a central broker and several clients, APC, sensors, embedded devices of any kind that will publish or subscribe on specific topics, payloads, binary data that's corresponding to the values you get from the sensors, the commands you want to send to the actuators. So this is the idea. And this protocol, we use it for doing bandwidth efficient communication, and we use it in the frameworks we provide, and we use it in Mihini, which we'll talk about in just a few minutes. So again, a few words about Paho. You have a dedicated website. We have implementations of the MQTT client maintained at Paho in Java, in C, in Lua. We have also tooling in Eclipse for helping you debugging what's happening when, for some reason, you're publishing data to the broker and you cannot seem to see it. We have a view for helping debugging it. We are hosting a free broker at Eclipse for you to play with and post your own messages and do your own solution. So we have Lua as a way to kind of program the embedded device in an efficient way. We have MQTT to communicate. So are we good to go? Can we do M2M with, we take a Lua VM, we take MQTT? Is it an approach which is viable? Not quite sure. What we think is important is to provide more than just a way to easily program embedded application, but of course you need more than this. You need a complete application framework, APIs for manipulating the IOs of your system, the serial ports, do some networking, access FTP servers, HTTP, have security, implementations of industrial protocols such as Modbus. So this is actually what we provide in Mihini. We have, on top of the Lua VM, an ecosystem of libraries, a set of libraries for doing M2M specific stuff. And Mihini also comes with an agent which by itself deals with the management of all the data queues that you will use when your third-party applications, your Lua applications, will need to send data to a server. We optimize the way the communication is done. We consolidate the data. We have a way to do network management as well. If you do M2M, you are likely doing stuff like your device is connected using Ethernet, and if for some reason the Ethernet connection is down, you may fall back to a GPRS connection. So for that, you need an agent that's taking care of using at some point in time using the best communication channel to send the data to the server. We also communicate with the server to do what we call device management. The agent is always listening to commands that the server may have for it, like a command for rebooting the whole system, a command for installing remotely a new application. So we have that kind of features in the agent as well, and we have everything also related to application management. So I'll give you a few examples of these features. One is what we call asset management. This is basically all the APIs for third parties, for user applications to actually communicate with a server. But we don't want the application to communicate directly with the server, because that might not be the best approach in terms of bandwidth. If you have several applications that want to send non-critical data to a server once an hour, it's better if you have an agent that's enqueuing all the data, optimizing the packets, optimizing the payload once an hour, for only communicating once an hour the data corresponding to all the applications that add information to send. We have also APIs for applications to be notified when a server is sending commands, applicative commands like turn a relay on or off, open a water valve. So we have these APIs, and the agent is taking care of making optimal communication with the server. So an example of the asset management API would be if you were to have a connected greenhouse, you would use the API to connect a new asset and manipulate a new asset. And then if you want to push data, send data. Oh. Okay, that's the cable, it seems. Thank you. So if you want to send data to the server, you would push data to the agent on behalf of a specific applicative asset like my greenhouse. And if I want to push a temperature data immediately, I could use a specific policy that's been configured in the agent before, and like the now policy. And if for some reason the humidity, I want to send it only once an hour, I just basically push the data to the agent, and I know that eventually once an hour the data will be sent to the server. So that's the asset management. Then we have what we call device management, everything related to reporting the status of the device itself. When you do an M2M solution, of course you will want to write your own applications, but you also want to manage the device itself. What's the signal strength of my wireless modem? What's my battery level? I want to reboot my system. So we have the agent is manipulating a tree, a device management tree on which all the variables related to device management are mapped. And in your application, you have a way to access these variables and to change these values. And the server is also able to interact with these values to basically know the value of the signal strength at some point, or to send a specific value in the device tree to ask for the device to reboot. So we have a standardized way of storing all the paths related to the wireless modem, to how the network is configured. Do you have VPN set up? If you want to change the settings of the VPN over the air, then you will manipulate the device tree over the air. So the API looks like this. When you want to do device management, you use the device tree module, and then you start by, if you want to access a value, you would use, that's quite simple, you use a getter on a specific path. Here that would be system.cellular.apn.apn. And if you want to know when a value is changed, whether because the value actually changed locally, that my signal strength has been changed, or the server has changed the configuration of the APN remotely, then you will register a specific listener, a specific callback on one or many paths, like here the RSSI. And when this will be modified by the server or locally, I will get a notification. I will here simply log it. And we also have an API for changing the way your device is configured. So the last main feature that the agent is taking care of is what we call application management. We have a language agnostic application container which can install, uninstall, run, stop applications and install them over the air. Basically, you communicate with the agent over the air to put specific information in some nodes of the device tree, and then the agent will react by noticing that at some point there's the URL for a new application package to download. So the agent will download the package, read a manifest that's inside the package, and install the package, run the application, or automatically take care of the fact that maybe the application will fail at some point. So the application container actually is totally language agnostic. So at the moment, what we provide with Mihini is this agent with an application container for any kind of applications. But if you, as of today, if you use Lua, you will not only be able to deploy application in the agent, but also use the APIs I mentioned earlier for communicating with the server, for doing device management. And that's basically the idea. In terms of application management, there's also a way to execute remotely any kind of script. You, again, the device tree, you write in a specific node of the tree, and the agent will know that this is a command that it has to execute, and it will put the result of the command in another node that we will be able to synchronize over the air, and you will know what's the result of the command from your server. So that is what Mihini is about. The project is we are still contributing the source code to Eclipse. It's still going under the intellectual property review, but it's going to be, the source code is going to be available pretty soon. And we actually already have a nice demo that you'll be able to see if you go upstairs on the booth of the Eclipse Foundation. And this is a demo where we use all the building blocks I just walked you through to build a use case, which is in the end a very common use case. We want to connect a greenhouse. We want to monitor to connect some gardening equipment. We want to remotely monitor what's happening with the wireless sensors like temperature sensor, humidity sensor. I want maybe to trigger some water valves to turn the light on or off. So I know I have that kind of business in mind. Yet I don't know what's the hardware I'm going to use eventually. So the idea is that with all these open source building blocks plus open hardware that's now getting more and more popular, I'm going to be able to prototype my solution. And the idea is that I will use a Raspberry Pi for doing all the embedded logic of getting the data out of my sensors and pushing the data to the server. And my gateway, my wireless gateway, is basically going to communicate with another kind of open hardware, which is an Arduino. And I know that eventually my greenhouse equipment will be talking using an industrial protocol. So why not use this protocol right from the beginning? And I will use a Modbus stack on my Arduino. So as I can, in my Raspberry Pi, start using the Modbus API to get the data from the sensors. So I will basically have a kind of simulator or emulator of my industrial PLC talking Modbus, and I will connect 2 Euros sensors to my Arduino to collect the humidity, the temperature. I may connect also some relays, and the idea is that I will have my fake PLC equipment, and then my embedded application will be communicating using MQTT with the public broker that we have at Eclipse. So you don't even need to get anything from to pay for having a trial account on some company server. You just use m2m.eclipse.org. You push data using the Mihini APIs. You push data to the server, and you can start prototyping your end-user mobile application that's subscribed to the MQTT broker, and that's notified as soon as data is available, basically. So for doing this, we're basically writing 2 applications, and one is the embedded application, which is using the Modbus APIs of Mihini to interact with the Arduino/PLC. We collect the data. We push the data using MQTT. We publish on specific topics the raw data, and we also subscribe to commands in case a client, such as the mobile client maybe, has some commands for us, like open a water valve, switch the relay on or off. So that's the embedded side. And we actually have another application on the mobile side, which is also written in Lua, by the way. Lua is popular not only in the video game industry, but also in the mobile industry. There are several frameworks for building mobile applications for Android, for iPhone. One is Corona SDK. It's not open source, unfortunately, but you can have a free evaluation version. And for me, it was really handy to use the very same. I mean, I use the same Lua MQTT client both on Mihini and on my mobile application. And what my mobile application is doing is subscribing to the topics corresponding to the sensor's data, displaying the data in a UI, and publish the data, publish some comments, publish on some topics when I have comments like switch the light on or off. So I'm not going to do the actual demo. If you come to our booth upstairs, the Eclipse Foundation booth, you'll be able to see the demo. But I do have a video showing you how it looks like. So the idea is that we have the Raspberry Pi in the middle, and this is the Arduino with sensors like temperature, light sensor. They are all connected to the Arduino, and between the Raspberry Pi and the Arduino, we communicate using the serial ports, using Modbus. And the idea is that we just then report the data to a server, and we have a mobile application which is displaying the data live. Like inside the flower is the humidity level. We also have widgets for the temperature, and we can see that when you push on the light, you're switching the light on and off because we are publishing a command on using MQTT. So that's all built using the open source Eclipse technologies, maybe not for the mobile application, which is, as I said, using a proprietary framework, but still we use the Lua MQTT client, open source client inside the mobile app. So that's pretty much the demo, and the idea is that with these building blocks, okay, you may want to prototype to do some crazy DIY stuff for your greenhouse or for connecting your fish tank or whatever. But what we also provide all these building blocks for is really for people to start building industrial solutions and have a nice transition between the prototyping phase and the industrial phase, where maybe you will have not only one but 100 of devices, of gateways, and this time you will probably need wireless gateways, and the sensors will be connected to a real PLC equipment. And on the server side, maybe on the long run, you will not want to use the public MQTT broker at Eclipse. Maybe you will need something more secure. You will need a server which provides integration with carriers if you manage your devices on the field. Not only do you want to manage your application's data, but also you want to manage, as we said, the devices themselves, maybe the SIM cards in the devices also. If you want to change the data plan of a device on the field, you need to have a way to interact with the carriers themselves. So for that, there are platforms like just Sierra Wireless is building a platform like that with integration with carriers, a billing mechanism. If you really are into the greenhouse business and you are selling connected greenhouses, maybe you want to provide your customers with a way, like for 10 euros a month, they will be able to use your solution. But if they use it for sending more data than expected, then maybe you will change the billing plan. So you need more services on the server side. And same for building the end user applications. You will need maybe more APIs than just the API for getting the MQTT data. If you want to do software upgrade campaigns of your devices on the field, MQTT might not be the best protocol, and you will probably need some other API. So, but still, the building blocks will be the same. The embedded gateways, they will be running the same Mihini framework. The tools you will use for developing applications for these gateways, these will be Koneki tools with maybe some proprietary plugins, but the core of the tools will be the same. The communication with the server, you will use the open source clients at some point. So that's the general idea of providing these open source building blocks. In the next, so as I said, we're still working on doing the actual contribution of the embedded framework, but we already have plans for the future, for the next few months. One thing we have in mind is, and we actually started already providing the specification for this, is a protocol which is quite similar to some extent to MQTT in that it's bandwidth efficient, but it's really meant for device management, not only the exchange of data related to sensors and the control of actuators, but it's also a protocol specifying how you can remotely interact with a device, and also in an efficient way. So it's called M3DA for micro M2M data access, and it's going to be part of actually of Mihini when the source code will be available. What we want to work also on is providing APIs, the framework, the agent. Today, the way it's designed, as I said earlier, there's this agent taking care of all the device management and providing an application container and providing a way for Lua APIs, for Lua application to do asset management. And the way the Lua applications are interacting with the agent is using, at the moment, a socket-based communication. So technically, it's absolutely possible to communicate on the very same socket. For doing Java application, you can use the socket to use the push data APIs I mentioned earlier. But we want to work on actually on a REST API. So as locally, if you want to have a Python application, a Java application that's pushing data and using all the asset management mechanisms of the agent for a Java app, we will provide that. This, by the way, will also provide even better tooling. What we have in mind is that these APIs, they will also expose the status of the agent. So as when you develop and you have like 3 applications pushing data to the agent, in the tool, you will be able to see what's the actual content of the data, and is the MQTT protocol really the best protocol for this specific use case? Shouldn't I use maybe just JSON for sending that kind of data, because I'm just pushing maybe a temperature every hour, and maybe if I use JSON it's more appropriate, I don't know, but I will have the tools for seeing the content of the data, for maybe flushing the data from the tools and see what's happening on the wire, how many bytes are consumed by such or such communication scenario. So that's that's the idea of the REST APIs. And as I said, it's going to be a way also to provide more enable development in more languages such as C and Java, using the same embedded runtime, the same embedded agent, which is meant to be really easy to embed. But if for your applications you want to use Java, for example, it's going to be possible. So that's pretty much the end of my presentation. So if you want more information, the main portal would be m2m.eclipse.org. And as I said, please come to our booth to see the demo live and ask us questions about how it's implemented. And it's pretty cool, actually, prototyping with Arduino, Raspberry Pi, and still being able to have bricks, blocks that eventually can be used for building industrial solutions. So with this, I thank you for your attention. I think we have time for questions.
Yes, okay. Let's start down here.
Hello. We're talking about Modbus here, but there are more and more devices that can be connected, or sensors that can be connected through USB, or there are things that I can collect data from through a REST API and so on. What kind of support do you have? Do you have a list of supported devices? Do you have any other protocols for collecting data that you support?
So we have, I'm not sure it's going to be part of the Mihini contribution. We have an implementation of a ZigBee stack. For sure, we can manipulate the serial port, so you can do pretty much everything over serial. But in terms of industrial protocols, I'm not sure we have that many. There are not that many open source implementations of of protocols like even Modbus. It's a stack we provide. But yeah, do you have other maybe protocols in mind that you
I
want?
was actually thinking about the iButton devices and
Yeah, for this
proprietary, but
yeah, we will need to look at how the API looks like and whether it's
Okay, further questions? So, yeah.
The MQTT broker, is that the open source product?
yeah, it's the one running at Eclipse. It's an open source project called Mosquito
Okay.
with 2 T's, yeah, double T-O, and it's an open source. It's written in C, and it's a broker which supports pretty much the whole specification of MQTT, and you can run it on. I think there's even a package in Ubuntu if you want to install it and,
All right.
and play with it locally. But yeah, it's open source.
Okay, thanks.
It's not in PAO though, but it's open source.
Yeah, any last questions? Okay, so let's thank the speaker. Thank you very much.
Thank you.